During a cyclone or storm, when one aspect of a house structure is compromised, then other parts may become vulnerable to further damage. This is especially true in the case of roofing. If the integrity of a roof is breached, water can enter the roof space, and in turn, this can damage the ceiling sheeting, electrical wiring, and wall material.
Okay, with the airbox test, we're trying to replicate the very high turbulence and high suction pressures that the edge of the roof is subjected to during a severe wind event. Here at the cyclone testing station, we break everything. If we want to know how strong something is, we break it. So the fact that it actually looks like this at the completion of a test doesn't mean it's failed. It just means we can work back from these loads and work out the most appropriate design criteria for this product to be used, whether it be on the house in a suburban environment, or if it's got cyclone assemblies on, be a house near the beach or on a hill.
During severe wind events, roofs are the most vulnerable part of a structure and the most frequently damaged. But regular inspection by a building professional and maintenance of roofing components will reduce the risk of failure. This is particularly the case for structures built in non-cyclone areas or for houses built in cyclone areas prior to 1980.
What we have here is a boundary layer wind tunnel. The wind tunnel is used to simulate the wind flow over the Earth's surface at a smaller scale, at scales ranging from 1:50 to 1:1000, and then build models of a similar scale, place it on the turntable you see here, measure pressures, and use that information for designing better buildings.
How these forces impact a roof depends on where the house is situated geographically and the shape and strength of the roof. Houses on hilltops and hillsides, especially those facing the sea, are subjected to stronger winds than houses built on flat terrain. Houses located on unobstructed terrain, such as on the edge of a large field, are also exposed to stronger wind forces. Fundamental to secure roof construction in order to resist uplift is the continuous tie-down chain from the roof sheeting down to the foundation.
This is new construction in a semi-rural area in southeast Queensland. The site is quite exposed, so it probably has a wind classification of N3 or N4. That classification leads to quite a high design wind speed, so you would have correspondingly quite high uplift loads as well as bracing loads that need to be resisted. So if we just have a look at the critical tie-down chain in typical construction, from the actual rafters and or trusses, the uplift loads have to be transferred down through to the external wall frame, connected to the top plate, and then in this particular case we have a girder truss, so we have a cyclone rod or a tie-down rod at the side of that girder truss connecting and tying those roof loads right through to the floor frame.
It's the continuity of tie-down from the roof sheeting through to battens to trusses to wall frames and right down to the foundations that is all important. If these aspects of house construction are present, then the potential for failure of the roof and roof frame during a severe weather event is significantly reduced.
So there are a few items I've noticed with your house.
As there are many older houses throughout Queensland, built before today's standards, you should seek the advice of a building professional if you're concerned about any aspect of the construction of your home.
This house here is actually having its roof replaced, but since the roof has come off, it's an opportune time to actually carry out some structural upgrades to the roof framing. So that is, not only would the roofing be screwed down in accordance with the current requirements, but it makes sense to try and fix the existing roof framing down in accordance with the current requirements as well, which would mean batten screwing the roof battens to the rafters and fixing the rafters to the top plate with either triple grips or straps or some other method of tightening.
Roofing especially should be inspected by a qualified building practitioner such as a building certifier, structural engineer, architect or builder.
With these older houses, those built prior to about 1980, it's important for homeowners to realise that they may not have the necessary tie-down in their roof area as is required by current building regulations and standards. And it's the tie-down in the roof and from the roof to the wall frames that is the most critical part in ensuring a good safe structure in the event of high winds and high uplift forces. In terms of tie-down chains, we've obviously got the connection of the roofing itself to the roof battens, and if we wanted to upgrade some of the tie-down at these points, we could use, for example, framing anchors or triple grips to connect that roof batten to the rafter or truss, depending upon the particular case. And you can use similar sorts of connectors that are readily available for upgrading, tying your roof battens to your rafters to your hip boards and ridge boards, and also your rafters down to your wall frames.
Even if work does not require approval by a building certifier, all licensed contractors should be aware of the building code and tie-down requirements. Any work they undertake on your home must adhere to these requirements. That is why it is important to engage a building professional with a BSA licence. Door and window failure is common during a storm or cyclone. If inadequately fixed to walls, door and window fittings won't hold up in a cyclone. The sudden entry of strong winds then changes internal pressure and risks roof and wall failure.
Within the different loads that could be on a structure, it's not only the wind load that we have to consider in this process. If you have like the winds coming and pushing on the windward wall, coming up over the roof, giving very large suction pressures on the leading edge of the roof, we can design our claddings for that. There is another force that could be in there, is that if there's any wind-driven debris from yards that haven't been cleaned up prior to a cyclone or a storm, parts of a broken house, bits of tree, whatever, that may come through and break a window, punch a door open, those sides, basically make a dominant opening. We have this sudden internal pressure that enters into the structure that works in concert or adds to the load that's on the top of the roof, which could double the load on that structure.
You can provide extra protection to windows and doors by having impact-resistant debris screens fitted, ensuring that door and window locks are strong enough to withstand the pressure of powerful winds. For guttering to do its job in heavy rain, it must be clear of leaves, dirt and other obstructions. Otherwise, the resulting backup can lead to water penetrating the roof and subsequently damaging the ceiling and walls. As a homeowner, it's important to have gutters checked regularly and, if there's any obstruction, have it cleared. Pressure caused by strong winds is a very common cause of garage door failure. They can be pushed in or blown out, causing the same consequences as the failure of windows and doors. Much of the damage to garage doors, windows and doors is caused by airborne objects. During a cyclone or storm, the everyday objects in this yard can be transformed into flying debris that threaten all homes in the neighbourhood. Trampolines, playground equipment, temporary shade shelters, barbecues and other outdoor objects and equipment should always be removed or properly secured with ropes and tie-downs during cyclone or storm seasons. Loose branches and overhanging trees should be regularly cleared from a property to keep it cyclone and storm safe. And it's not only unsecured items and vegetation that pose a threat. House attachments such as porch roofs, whirlybirds, carports, lean-tos and screen enclosures can simply be torn off in strong winds. This leaves the house open to further, more serious damage And of course, it creates more flying debris in the neighbourhood. During good weather, it's easy to underestimate the power of cyclonic winds, so it's important to maintain awareness about what's in your yard. Ask yourself what kind of damage these things could do if they became airborne. In this program, we've looked at some of the most common types of cyclone and storm damage. To recap, they are roofs being blown away in whole or in part, damage to housing in exposed locations such as hills or sea frontages, damage to ceilings and walls due to water ingress through roof, doors, windows, vents, etc. Doors and windows being blown open due to inadequate fixing, flying debris breaking doors and windows, resulting in further damage from water leakage and strong winds. Garage doors being blown in or out, damage caused by flying debris from yards. Regular maintenance and attention to these areas will help reduce the risk of damage from strong winds. Anything that weakens houses, such as rust, rotten timber and loose fixings, can make them vulnerable to cyclone and storm damage. As a homeowner, you can check the parts of your home that are most likely to fail during strong winds. Further information on the topics covered in this presentation can be obtained from these websites. The Building Services Authority has prepared a checklist for homeowners to assess their homes for cyclone and storm preparedness. And the Is Your Home Prepared for a Cyclone guide can be downloaded from the Cyclone Testing Station website. As a homeowner, you have a responsibility to identify problems and initiate solutions to protect your home from damaging winds. We may not be able to stop cyclones and storms, but with some attention to inspections and maintenance, we can reduce the impact they can have on our homes and our families.